Alright, so today's lesson is Intro to Inequalities. So we've done a lot of exploration with equations and how to solve them in their various forms. And now we're going to get into solving and then graphing inequalities. Now, when I say graphing an inequality, it's on a number line because when you have an inequality, you have more than one solution. So the graph of the inequality represents all possible solutions to that problem. Okay, now that's usually an infinite amount of solutions. We'll talk about some inequalities that have a limited amount of solutions but still multiple solutions. And remember, that just means multiple values for that problem. Okay, and usually we read inequalities from left to right. Okay. That's just a standard that I like to teach. You can read them from right to left if you're comfortable with that, but I just like to go from left to right. So this one says that x is less than 2. Okay, so when the point is towards something, it implies it is less than whatever comes after. When the point is greater than, or when the point is away from something, or the thing is open towards something, it implies that it's greater than whatever comes after. So this says that -3 is greater than y. Okay. The next one, why don't you guys try the next two? See if you recognize these signs from any other math classes that you have. Pause the video for a second. Okay, so what you should have gotten is that x is less than or equal to 1. And this little bar underneath implies that x can also be equal to 1. Doesn't always necessarily have to be less than it. Okay, so number 4, I've got 3 is, well, it's open toward the 3, so it's greater than. And that little line implies that it can also be equal to, so or equal to y. Okay, so that's the basics of how to read inequalities. Right? Now we'll have to be able to graph them. Okay, so for the first inequality I have x is greater than 3. So I always include on my graph at least the 0 spot so that I know where the middle of my number line is. And then I include any numbers in my inequality. So 3 is greater than 0, so I'm going to put that somewhere over here. And I want to graph all of the possible solutions x is greater than 3. So anything greater than 3 is, for instance, like 4, 5, 6, etc. So I'm going to mark that 3. Now it says it has to be greater than 3, so 3.01 works, but 3 doesn't. So I can't include 3 in my solution. I'm going to use an open circle to graph that. So this implies that 3 is not actually in my solution, but literally everything starting at 3.00001 after that is. It's greater than 3, it's in the solution, but 3 itself is not. Okay, and the inequality x is greater than or equal to 4, so I'm going to start again at 0, and then over here to the left, put my 4, when everything greater than 4. So some possible things that are greater than 4, got 5, 6, 7. So my graph is going to go to the right. Okay, but in this case, x can be equal to 4. So I'm going to represent that with a closed circle because I am including the 4 in my solution. It can be equal to 4, but also greater than 4. So everything greater than 4. So when graphing a greater than or less than function, we use an open circle. And the reason for that is that solution is not included in the answer. Okay, so keyword, not included. Okay. When graphing a greater than or equal to, or less than or equal to, we use a closed circle, because that solution is included in my final answer. Okay, so remember this explanation. We're going to be asking that a lot throughout this semester. It means is included. Alright, so solving and graphing inequalities, well, I'm going to solve these exactly as if I had an equal sign here. It follows all the same rules. Whatever I do to one side, I have to do to the other, because if I don't, it changes my problem. So I'm going to pretend like this is an equal sign for now and solve for x. Okay, so to get x by itself, I need to do the opposite, subtract 7, and then add 7 to both sides. Okay, so that drops out on this side, and then x is left greater than negative 6 plus 7. So my sign carries down. I don't change the sign yet. Okay, so x is greater than 1. Okay, so I have solved. X is by itself. The answer is for every x greater than 1, this problem is greater than negative 6. Or this side over here is greater than negative 6. Okay, so to graph my solution, read from left to right, I've got x is greater than 1. Okay, so I'm going to start out with my 0, and then 1 is over here to the right of 0, because positives to the right, negatives to the left. Okay, greater than, open circle. This does not include the 1. Okay, things that are greater than 1, we'll try some stuff. Is 2 greater than 1? Yes. So it's going to go this way. 0 is not greater than 1, so it's not going to go this way. That's one way you can check. You can just throw in 0. If 0 makes the problem true, then you go the direction towards 0. If 0 doesn't make the problem true, you go the opposite direction. Okay? So in this case, if I put in 0, 0 is not greater than 1, so I want to go the opposite direction, to the right. Okay, so it's all solutions greater than 1. Alright, so pause the video real quick and try number 2. Okay, so what you should have done, alright, I've got x plus 2. So I'm going to subtract 2 from both sides. So x is less than 7 minus 2, which is 5. Okay, so I've got to graph this, read from left to right. X is less than 5. So I need my two important points, 0 and 5. Right. It's going to be, since it's less than, an open circle. Okay, so I don't want to include 5. Is 0 less than 5? Yes, it is. So I'm going to go toward my 0. Alright. So not only do we have to add and subtract, we have to multiply and divide for these types of problems, but it's, like I said, almost the same as an inequality. And there's one special rule that we're going to talk about today with multiplication and division. Alright, so we've got x divided by 3 is greater than 5. So I need to solve for x. Division by 3, you need to do the opposite. So I'm going to multiply by 3 on both sides. It's going to drop the 3 out here, so I get x is greater than 15. Okay, so check the 0. If I plug in 0, 0 is greater than 15. Nope, that's not true. So I need to mark my point. It's open circle because the 15 is not included. There's no equal sign under here. and I want everything greater than 15, so I'm going to go to the right, away from 0. Alright, the other thing, next one, we got B, 3x is greater than or equal to 15. Okay, so I'm going to divide both sides by 3. Get x is greater than or equal to 5. Okay, so put the 0 on, graph the 5, greater than or equal to, so that means I use a closed circle, looking for that line underneath because it tells me that it can be equal to 5. Check my 0. Is 0 greater than or equal to 5? Nope. So I'm going to go to the right. Okay. So it's everything greater than 5. So 6, 7, 8, 9, 10, etc. Alright. There's one special case with inequalities that isn't the same as with equalities, and that is that if I multiply or divide by inequalities by a negative number, we must flip the sign. Okay, and the reason for that is thus, because watch, if I say have 10 is greater than 5, this is true, correct? So 10 is greater than 5. Now if I follow my rules of equality and I divide both sides by a -1, I get -10 is greater than -5. Now I followed my rules, I divided both sides by -1, but is this true? Think about that for a second. Is -10 greater than -5? Well, let's look at that on a number line. So on my number line, I've got 0, right? -5 is somewhere over here, and -10 is down here. So my 2 points, -10 and -5, well, -10 is definitely not greater than -5 because things that are more right, so to the right on a number line, are bigger. So -5 is actually the bigger number here. So to keep my statement true, I have to flip the sign whenever I divide or multiply by a negative number, because by that same merit, I could take the same problem and multiply by -1, and the same thing would happen. Right? I get -10 greater than -5, which is no longer true. So I have to flip the sign because I'm flipping my number line. Okay. So my 2 examples. Got -n over 2 is less than 5, so I'm going to multiply both sides by -2. The -2 drops out. I've got n all by itself. This becomes -10. Right? And just like in my previous example, I'm multiplying by a negative number, so I need to flip my sign. It's got to go from less than to greater than. Okay, so I've got n is greater than -10. Okay, so I put my 0 on here, mark my -10, and then check 0. Is 0 greater than -10? Yes, yes it is. 0 is bigger than a negative number. So I have open circle because there's no equal sign underneath here. I'm not going to include -10 in my solution, and I want to go toward the 0 because I checked my 0, didn't work, or it worked, so I want everything included toward 0. Okay. Last example, pause the video for a second. I want you to try this one on your own. Okay, so we've got -4x greater than 20. Okay, so to solve for x, I'm going to divide by -4 on both sides because this is -4 times x. It's going to drop out. We got x 20 divided by -4. You should have gotten -5. But now I've divided by a negative, I've changed my sign, so I need to flip, or I've changed the sign, so I need to flip the sign. So I got to make that less than 5. So we got x is less than -5. Okay, so go to graph, put on the 0, put on the -5. Remember, open circle because there's no line underneath. We don't want to include the -5. Now test your 0. Is 0 less than -5? No. No, it is not. So my solution is going to go away from 0. Right? Everything less than -5. -6, -7, -8, -9, -10. All right. Thanks for watching. bring this to class tomorrow so we can talk about it. Have a good night.